Akwaba to the math classroom. Kindly don't forget to subscribe if you are new to the channel. And to my already subscribers, I'd say thank you. Our lesson today, we are solving an example on homogeneous differential equation. So let's take an example of a differential equation. So let's say I have x minus y dx plus x dy to be equal to 0. What do you realize? You realize that this differential equation is of the form m of what? Xy dx plus what? N of what? X y dy to be equal to what? 0. So this is what? The differential form we are looking at. So we want to solve this differential what? Equation. So let's say it is what? Not separable. So this differential equation, let's say it's not separable. So I can't use the method of what? Separation of what? Variables. So I want to check if the coefficients of this differential equation are what? Homogeneous. And if they are homogeneous, then I can use the method of what? Substitution here. Okay, so to check whether they are homogeneous, let's look at m. Let's say m of what? X, y here. It's equal to what? X minus what? Y. Okay, so we can actually check. So let's have m. So I have m of what? Lambda x, lambda y, which is going to be equal to what? Lambda x minus what? Lambda y. And I can equally write this as what? Lambda what? X what? Minus what? Y. So what do you realize? You realize that this is still our what? M. Then we have what? The degree here, lambda to the power what? 1. Okay. So then let's check for the other side as well, where I have my n of what? X, y to be equal to what? X. So that if I have n of what? Lambda x, because it's just lambda x, then I have what? Lambda what? X. So this is what? My n. And I have to the degree what? 1. So you have to the degree 1 and to the degree what? 1. So you realize that the coefficients, so our coefficients of the differential equation, I'm using dE, are what? Homogeneous. And because they are homogeneous, I can therefore use the substitution method. And what is the substitution method? From our previous lesson. So from our previous lesson, this is substitution. We are saying that, so we are saying you have, so let's do the substitution. And with the substitution, you have y to be equal to what? X v, and dy is going to be equal to what? X dv plus v dx. So this is what we are using. Okay, and our initial equation differential equation is what? X minus y dx plus x dy to be equal to what? 0. So wherever I see y, I put xv. Wherever you see your dy, you have what? X dv plus v dx. Okay, so let's do the substitution. So this implies that I have what? I have x minus y. Y is what? xv or vx dx plus x dy is what? X dv plus v dx to be equal to what? 0. So let's do the algebra here. If you simplify, what do you have? You realize that we have this x is common here, so I could have, you can factorize x out so that I have 1 minus v, so that I have x out dx. Plus, let's simplify this. So this multiplies that, and it multiplies what? This as well. So you realize that I have what? X squared dv plus I have v x dx to be equal to 0. The purpose for doing this substitution is just to make our differential equation what? Separable, so that we could solve using the method of what? Of separation of what? Variables. Very good. So with this, let's continue to what? Simplify. So if I continue to simplify, what do you realize? Or let me put it in the previous form so that I have, let's say from here, if I even decide to simplify, you realize that I have x dx minus vx dx plus x squared dv plus vx dx to be equal to what? 0. So you realize that you have this and what? That. So they cancel out. If you add this, you realize they cancel out. So we have x dx plus what? X squared dv equal to what? 0. So we want to separate the variables. So we want to have the x and the v separately. So if I do that, you realize that I can take the v to the other side so that I have x dx to be equal to what? X squared dv. So because it crosses the equal sign, it becomes what? Negative. So let's divide through by x. If I divide through by x, what do you realize? You realize that I have what? Dx to be equal to what? Okay, so let me divide through by x squared rather, because that's the highest, so that I have 1 over, so this will cancel that, so that I have 1 over x to be minus what? The v. Okay, so let's write it out nicely. In writing it out nicely, you realize that we have what? Have 1 over x dx to be equal to minus what? The v. Whoa! What did we just do? Now it looks like this is what? Separable. We've been able to group them. So then I can solve this. So what do we do? To do that, let's take the integral on both sides. So you take integral on both sides. And if you do that, you realize I have the integral of 1 over x dx to be equal to the negative integral of what? The v, which should give us the integral of 1 over x is giving us what? Ln of what? X. And this is giving us what? Minus what? V plus what? Your c, a constant c. And you can write x to be equal to what? The exponential minus v plus what? C. But you realize that our initial equation was not of the form what? V. So we can actually, so this is what our solution. But we know that from here, we said y it's equal to what? V8. So that if I want to find v, I know that my v here is going to be equal to what? Y over what? X. So I can write my final solution of the form x to be equal to e exponential minus y over x plus what? My c, which is what? A constant. And this is our solution to the differential what? Equation. That is, if we have a homogeneous what? Constant. So first check, we go through, you first check if your equation is what? Separable. And if it's not separable, you can check for the homogeneous coefficients to use the substitution method to solve. Thank you so much and kindly stay safe.